Okay, for those of you who might just want one more example of this process of finding all the real zeros of polynomials, here is one last example for you. So this is kind of an optional one. If you think you have the process, go for it. But if you just need to see one more problem worked out, this is for you. So here is our problem, 3x to the fourth. Okay, so it's a polynomial that is a degree 4. So first of all, we know that we have up to 4 real zeros. And we know our first step is to find all the possible rational zeros. So all possible rationals. Okay, so that's the P over Q. So P in this case is the factors of 6. This last term is 6. So plus or minus 1, 2, 3, and 6. And Q in this case is 3. It's that leading term. So it's plus or minus 1 and plus or minus 3. So P over Q, the possible rationals, remember that it's all the first P's are over 1. So plus or minus 1, plus or minus 2, 3, and 6. And then we have to put all those numbers over 3. So plus or minus 1/3, that's P over Q, plus or minus 2/3. Okay, now 3/3 is 1, so we already wrote that one, and 6/3 is 2, so we already wrote that one. So actually, I am done. I just have 2 sets of fractions in there. All right, step 2 is to look at the graph and find all of the good rational zeros. So here, I've plugged the graph into y equals, and I'm looking at the graph here. Remember, it is a 4th degree graph, so I feel like I can see the whole thing, even though I can't see the little tops and bottoms, because since it's 4th degree, even degree, and it's positive leading coefficient, it's up and up, or the end is the end behavior. Okay, when I'm looking at this graph, someday, hopefully, it will graph. There it is. So what I'm seeing is it looks like there's a little fraction here, a fraction here. This looks like it goes through 1 and then another fraction. And so I think some of these might be, it could be 1/3. Remember, we could have 1/3 or 2/3, right? So, and I think this one is 1, and I can see that 1, 0, right? So let's just calculate like one of these zeros. Calculate, and then 0. Let's go over to the left. So I'm going to type -2. You can arrow to the left, or you can actually tell it a left bound. And then I'm going to say right bound is -1. You can arrow to the right, but see how I'm getting in between this 0? It's somewhere between -2 and -1. There it is. It's -1.30. No. Right? That is an irrational number. So I gotta try again. Okay, so good thing I have a calculator for this. All right, so this time I'm gonna do this second possible 0 here. So I'm gonna say my left bound is -1 and my right bound is 0. Okay, I'm doing the bounds a little differently because I like to just type the numbers in instead of arrowing left and right, okay? But I just bounded it between here and here. And now my guess, okay, I'm hoping, okay, so look at my 0, right? Here it is. It's negative 0.66666666, right? That, hopefully you recognize that anytime there's a repeating decimal, that can be written as a fraction, right? And that's 2/3, right? If you try to type 2 divided by 3, you're going to get that number. So you, and the reason I was looking for 2/3 is because of my list, right? So I would look for either 1/3, which is 0.3 repeating, or 2/3, right? So graph and find rational zeros. So far, this is what we have found. We have found x is equal to, what did we have? We had -2/3, and we also have 1, -2/3, +1, we already saw. And if we look and if we do this other 0, it is not a rational number. And actually we can tell because this is greater than 1, but none of our fractions were greater than 1, okay? So we just have these two, so I'll erase that. Okay, so we have 2 good rational zeros. So see if you can remember what comes next while I make some more room. Okay. So what we need to do next is divide out our rational zeros using synthetic division, right? So these are the zeros. Remember that the factors would be x plus 2/3 and x minus 1. Okay, this x plus 2/3 can also be written as 3x plus 2. Okay, notice that that is the same zero, right? If you set this equal to 0, you would get negative 2/3 as a 0. Okay, all right, so let's put 1 on the shelf first, just to make it a little simpler. And here are our coefficients. Okay, and do your synthetic division. And of course, we want the remainder to come out as 0. All right, now we have to put 2/3 on the shelf, or sorry, negative 2/3 on the shelf, our other 0. Okay, that's okay. It works the same way, follow the same steps, it's just there's a little extra step at the end. So that's there. It usually works like really well with the numbers. If it's not, then, oh, this is positive, right? Then something went wrong, and that's how I knew something just went wrong. Okay, and then finally, that does equal 6, and so this does equal 0. Yay! Okay, so I don't know if you remember when we practiced synthetic division, when you have a fraction on the shelf, you need to adjust your synthetic division by dividing by that denominator again. So divide out that common factor of 3, okay? And so you're going to get x squared minus x minus 3. In this case, if you don't do that, you're setting this equal to 0 and solving, you're going to get the same answers, but it is better to divide that out. Okay, so this is step 4, right? I'm trying to go a little faster, even though these problems do take forever, but because, you know, we've done them a couple times. So you would either factor this, but of course, it's not factorable, so you have to use the quadratic formula. So a is equal to 1, b is equal to -1, and c is equal to -3. So do the quadratic formula here. The opposite of b, plus or minus the square root. B squared, -1 squared is +1. And then minus 4ac, all divided by 2a. So that's 1 plus or minus, now that's 1, I'm looking at plus 12. So I think it's the square root of 13, all divided by 2. Okay, so that's not going to be able to simplify any farther, right? So those are our other two zeros. So to finish the problem, we just need to list out all of our zeros and write this in factored form. So let's see if we can do that. Okay, now the zeros that we had, there were 2 that were rational zeros, and those were -2/3 and 1. And then our other 2 zeros are 1 plus the square root of 13 over 2 and 1 minus the square root of 13 over 2. They ain't pretty, but they are, you know, our zeros. They are our irrational zeros. Okay, and then in factored form, the polynomial would look like f of x is equal to, remember we said x plus 2/3 or 3x plus 2. Okay, that's going to give us that leading coefficient of 3 that we wanted. Then we have x minus 1. Then we have x minus 1 plus root 13 over 2. And x minus 1 minus root 13 over 2. Okay, and that's fine. It doesn't look really nice, but that is our exact answer, and those are our zeros.